Hi everyone, my name is Elise and I'm with the University of Rhode Island's Inner Space Center. Right now I'm coming to you live from RV Endeavor located off the coast of Rhode Island. From now until September 6th, we're going to be broadcasting live with scheduled shows at 11, 1, and 7. These shows will be broadcast on Rhode Island PBS and also online at innerspacecenter.org/RIREX. Joining me now is Dwight Coleman, the director of the Inner Space Center, and he's going to tell us a little bit about what we can expect to see on this cruise. Dwight, thanks so much for joining us. Why don't you start by introducing yourself?
Great. Thank you, Elise, and welcome everybody. So I'm Dwight Coleman, the director of the Inner Space Center at the University of Rhode Island Graduate School of Oceanography. And GSO has been around for more than 50 years. It's loaded with scientists and students that study oceanography. And one of the main systems that the university operates is the RV Endeavor. And that's the ship that we're on right now. And it's really one of the key oceanographic pieces of equipment that we use to study the oceans. We need the ship to get out to the oceans. So we are live on the RV Endeavor right now. And we're on a project that's actually funded by the Rhode Island Endeavor program. So this is a state of Rhode Island funded project to offer ship time to local scientists, URI scientists and GSO scientists, but also other scientists and engineers and students and teachers around the state of Rhode Island that can participate live in research cruises. So the Graduate School of Oceanography is where I work, and that's also the home of the Inner Space Center. So the Inner Space Center is really the facility that supports telepresence. So we have a mission control facility there. We also have a production control facility there. So the ISC is really what enables this broadcast to happen. So we have a live ship-to-shore telepresence connection. So there's a satellite tracking antenna on the ship, on the Endeavor. It's always keeping lock on a satellite, and we can stream all of our video, audio, and data and actually get an internet connection through that satellite connection. So that's what we call ship-to-shore telepresence. We've been doing this a lot with other research ships that have strong connections to the University of Rhode Island. One is the EV Nautilus, another is the NOAA Okeanos Explorer, and they've been supporting telepresence operations for about 6 or 7 years now, ever since the Inner Space Center got built. So we continue to support those ships, but this is really the first time, and we're very excited about having a telepresence capability on the RV Endeavor. So we featured this project to test the telepresence system and also build this partnership with RI PBS. And what we're hoping is to continue this partnership into the future and make telepresence activities on board the Endeavor accessible by the Rhode Island public and broadcast live to different websites. So you can check us live on innerspacecenter.org and /RIREX is where you can pick up the live feed. So you can always watch along 24 hours a day, and that's what we do with the other ships that we support. So I want to just introduce what we're about to do on the project. So we're out here for about another 3 or 4 days, and a couple of key team members are making all this happen. So we have the Inner Space Center production team, which includes Alex DeCiccio, who's the mastermind or wizard behind the curtain that's switching the program live as we produce this broadcast, and myself, of course, Elise, Erin, Andrea, Kyle, and others from the Inner Space Center that are making it happen behind the scenes. We have a team of people that are behind the scenes at URI, also making sure that the quality of the feed going out is excellent. So we also have a couple of professors here that are doing various projects on the ship. So the first one that I want to introduce is Tom Rossby. Tom Rossby is a professor of physical oceanography at the Graduate School of Oceanography. He's a veteran of many cruises on the RV Endeavor. He studies ocean currents, but he's also an expert in underwater acoustics, and he's developed a sound source that can be used as part of a fish tracking experiment. So we're trying out new technology. Gabes Fisher is also on board with us. He's a professor of electrical engineering, and he's actually developed a fish tag. In this project we called Fish and Chips. So with this project we actually are testing these new chips to make sure that we can listen to a acoustic source that's deployed on a buoy. And so we deployed that buoy last night actually and tested it for the first time, and we have a bit more to do to practice with that buoy, and we'll be deploying it again later on today. So Tom's going to measure the acoustics with a hydrophone, and Gabes is going to measure the receive strength of the acoustic signal as well. And this could be a future project where we can deploy these chips on fish and actually track their movements, and that can help us manage fisheries better. So another team that we have on board during this research is a professor of ocean engineering. This is Stephen Licht. Professor Licht has two of his graduate students out here with us. One is Jordan Kirby and the other is Matthew Perkins. And they are part of the ROV team. So they have an ROV called the Falcon. It's actually called Deep Reef is the name of it. It's a CI Falcon ROV. And we've just deployed it this morning, and we're working on some electrical problems with it. And we hope to be diving this ROV on some shipwrecks pretty soon. So Professor Licht and his team have been working very hard to get the Falcon ROV ready. We're going to deploy it again later today and do some test dives. Hopefully we'll solve this electrical problem and then kind of continue with the ROV dive. So right now we're pretty far from these shipwreck sites. We're off the south coast of Block Island, and we're in basically bluer water, deeper where currents are less strong. We had a lot of challenges with the ROV yesterday working around high currents off the coast of Block Island. When the tide flushes out of Narragansett Bay and flushes out of Block Island Sound, we get strong currents. So we have to really be careful how we dive these ROVs during slack time. So the next person I want to mention is Mike Brennan. He's with the Ocean Exploration Trust. He's a graduate of the University of Rhode Island GSO, and he's an archaeologist. So Mike's with us here, and when we do these dives on the shipwrecks, he'll lend his archaeological expertise to the project. He'll provide commentary about the history of these ships and why we need to protect ships as cultural resources, and work closely with the scuba diving community who also value these shipwrecks as for their recreation. And Mike is a veteran of many cruises with Dr. Robert Ballard looking at shipwrecks, including ancient shipwrecks in the Black Sea and the Mediterranean, and modern shipwrecks, including U-boats in the Gulf of Mexico. So we'll be working closely with Mike. And then we have two partners from the Coast Guard Academy. We have Rich Sanders and we have Gabe Patterson. So Rich and Gabe actually are lending their expertise to this program. They have a small ROV called a Seabotics ROV. And this is some new technology that they've acquired, and they're using the Endeavor as a test bed so that they can get some practice operating their ROV to look at shipwrecks as well. And they have a mission to actually investigate shipwrecks as potential environmental hazards. All these shipwrecks have oil in them, and they could leak the oil, much like the USS Arizona is doing in Pearl Harbor now. And so the U.S. Coast Guard has a program in place to actually monitor this and investigate this and react to it too. So this is something that Rich Sanders and his team will be doing, and we hope that this partnership continues in the future too. So right after this program, in about 20 minutes or so, Rich will be deploying his Seabotics ROV over the side, and we'll do another test dive and take a look at the seafloor and the marine life that's living around here, hopefully. So the next team that I want to introduce is Rhode Island educators. So we have two Rhode Island educators. One's on board right now. That's Shannon Donovan. She's from Scituate High School. She's a science teacher. So we're looking forward to talking to Shannon in just a few minutes, actually. And she's out here just learning everything she can about the science, about the mission, about the technology that's applicable to her students in her classroom and the classes that they're taking. So she's already been doing interactions live with her classroom through the telepresence connection. And she did a couple yesterday, and she did one already this morning. So we also have Tiffany Risch, who's from Coventry High School. She's not on board yet, but she's joining the ship tomorrow. So we're looking forward to working with Tiffany. She's been with us before on the EV Nautilus when we've done some live programming in the past, and she's also been connected to the Okeanos Explorer program. So we're looking forward to working with Tiffany on that. And so the Rhode Island Teacher at Sea program and these Rhode Island educators are key to this whole project, because what we want to do is not just broadcast live to the public or to Rhode Island PBS or to the internet, but we want to be able to broadcast live to Rhode Island classrooms. And a lot of classrooms around the state of Rhode Island have high bandwidth internet, and they have this telepresence capability. They have smart boards, they have video conferencing systems, so we can do live connections directly into Rhode Island classrooms. And what better way to do that than to educate about oceanography for the ocean state with kids and high school students around the state to learn more about the ocean live from activities on board the Endeavor. So now we want to just segue into what we're up to right now. So like I mentioned earlier, we were off the coast of Block Island, about 40 miles south of Block Island, to do this acoustic experiment with Tom Rossby and Godey Fisher. And we did that through the night last night. So we worked 24 hours a day on this ship. We've just recovered that buoy this morning. Now we're transiting back north towards the shipwreck site. So we're still a few hours from the shipwreck sites. We're going to do some practice ROV dives before then. But then eventually later on this afternoon we'll be back on those shipwreck sites to do a dive. And so these shipwreck sites are very interesting, and we want to be able to tell the story of the history of the Battle of Point Judith, the U-boat U-853, which is a popular scuba diving target that recreational scuba divers go to frequently. It sank on May 5th, 1945, in one of the last battles of World War II. It was really the last U-boat attack on American ships in the Atlantic Ocean. So it was one of the last sea battles of World War II in the Atlantic Ocean. And the U-boat sank another ship called the Black Point. And so the Black Point is another target that we may hopefully dive on. We tried to do that yesterday, but currents prevented us from getting there, unfortunately. So we will try later in this week to dive on the Black Point. It was a cargo ship carrying coal to Boston and was the target of U-boats. All commercial ships were targets of U-boats during World War II. And this was one of the last commercial ship casualties of World War II, sunk by the U-853 when it shot its torpedo and basically took the transom off the ship, and it sank. And many people were rescued, but several died on that disaster. And then the U.S. Navy got the word that this attack had happened, and they sent out 2 ships to drop depth charges on the U-boat. First, they found it with sonar. Actually, it was a Coast Guard cutter or frigate that actually located the ship first. And then other ships came to the engagement and dropped depth charges, and they confirmed the hit of the U-boat. And U-853 was lost with all hands. I believe about 55 German sailors died during that sinking. And so we'll be diving on the U-boat. We'll be telling the story of the history of this battle. We'll be looking at the integrity of the ship, diving the ROV around different parts of the shipwreck to basically look at its condition on the seafloor and try to do some assessment of its status. And so we're looking forward to explaining that whole history to the public audiences that are watching and kind of going from there. So we'll be telling the story of the shipwrecks, we'll be telling the story of the battle, and then we'll also be doing the ROV dives and telling the story of the technology that we're using, and maybe even diving on a rocky reef and looking at some fishery habitat south of Block Island too. So that's the long story of what we'll be doing the next couple of days out here. And what we'll do now is see if we have any questions. So we can go to Marie Elise to see if there's any questions.
We do have a question. Are there any environmental impacts from these wrecks we're going to be looking at?
Well, that's a great question, and that's one of the things that we're going to be looking at out here. Absolutely, there's environmental impacts. Certainly when some large shipwrecks sink, the Costa Concordia, for example, that sank off the coast of Italy, these are major disasters, and they do affect the environment. Absolutely, it's unnatural to have a ship run aground or on the seafloor. So there's actually some threats with oil and gas leakage, and that can cause basically a catastrophe for the marine life that's living around there. But this also could be beneficial. A shipwreck is actually a artificial reef down there that actually becomes a site where fish congregate, where fish live and grow, and recreational fishermen love to see what they can catch around shipwrecks, and they can be stepping stones to other habitat for fisheries and other animals that are living on the seafloor. So there's benefits to shipwrecks as well. Any more questions?
We do have another question. This student wants to know how they can get involved in this type of research.
So that's a great question. So we are oceanographers. Basically, we're scientists. So if a student wants to become an oceanographer or become a scientist, certainly they need to do well in math and science and study hard all through grade school and all through high school, and then apply to college. And most everybody on board here has college degrees, usually with a science background, and at least a bachelor's degree. In the case of me, I kept my studies going until I earned a PhD, and there's several others that have master's degrees as well. So the best way to get involved on the science side of things, or the engineering for that matter, is study hard with math and science and enroll in a program, a college program like URI's, where they can study that and become a professional engineer or a professional scientist. If you want to just get involved casually, you can follow us along on different websites. You can just be basically a supporter of science and someone who reads a lot of science and just keep up with different oceanography topics. There's plenty of material on website that you can read and become involved. Any more questions?
We do have another question. The question is, what can we learn from shipwrecks?
Good question. So shipwrecks are interesting targets. We can learn lots. Working closely with Dr. Robert Ballard through the University of Rhode Island and the Ocean Exploration Trust, we've studied ancient shipwrecks. So by studying ancient shipwrecks, they're really time capsules of a certain moment in time by a certain culture of people. So by studying the artifacts that are left behind by these people, we can learn a lot about their history, learn a lot about their culture, learn a lot about the goods that they were moving across the ocean or across the seas, and understand more about human history and human activity on Earth, really. That's ancient shipwrecks. More modern shipwrecks, we can learn a lot by studying them because something that I mentioned before, these become now artificial reefs and animals grow on them. And there's a lot of interest in looking at how shipwrecks affect the environment and how shipwrecks actually benefit the environment. So it's worthy to study shipwrecks because we want to understand more about how they're evolving essentially since they sank in the natural world that they live in, and how they're affecting the environment and how animal life is then congregating around them. So shipwrecks are worthy of study for that reason, but also just understanding the history to look at shipwrecks that we don't know much about, like say from the colonial era. We can study about what cargo they were carrying, what people were on those ships, and what objects we could find on the shipwreck too. So there's a lot of people that study shipwrecks that sunk in the Caribbean, for example, and they're worthy of study as well. So lots of great reasons to study shipwrecks. So do we want to do one more question?
I think we're going to go to our next guest.
Sounds good.
Thank you so much, Dwight.
Good.
So our next guests are Captain Rich Sanders from the United States Coast Guard Academy and Shannon Donovan from Scituate High School in Rhode Island. Thanks so much for joining us. Why don't you start by telling us a little bit about yourselves and why you're here?
Shannon, why don't you go ahead to start?
I will. My name is Shannon Donovan. I teach at Scituate High School in Rhode Island. I am a high school science teacher. And last year, I started teaching robotics for the very first time in my school. So when I saw the application for the Teacher at Sea program come up, I thought this was a great opportunity for me to get some really good experience that I could bring to my students. And when I came aboard, I met Captain Sanders, who is doing exactly the kind of stuff I aspire to achieve with my students, which is some really interesting applied work with his students, developing robots that serve an actual, real, useful purpose.
And good morning, everybody. I'm Captain Richard Sanders. I'm a professor of chemistry at the U.S. Coast Guard Academy. Quick shout out to all my organic chemistry students who are in lab right now. I teach at the Coast Guard Academy, and in addition to chemistry and professional training, also am involved in subsurface research and capability, which is cadet-focused and cadet-centric research.
So that's fantastic that you have that opportunity to do that. A lot of teachers these days are frustrated by the lack of flexibility they have in their classroom to do these kinds of applied learning projects. So I was wondering if we might be able to bring one of your cadets on with us to show us the robot and maybe tell us a little bit about how he got the opportunity to work with you and to be here on this ship with us.
I think that's a fantastic idea. Let's go ahead and introduce Cadet First Class Gabe Patterson, who is the Coast Guard Academy's ROV pilot, and he also runs all of the training and all of the development for the other cadets who are involved in this. So let's go ahead and say, Gabe, welcome aboard.
I'm going to scoot over here.
Sure.
Welcome, Gabe. I was wondering if first you might tell us why you decided on the Coast Guard Academy. How did you come to be a cadet, and what did you do in high school to prepare to be accepted once you decided that you wanted to follow that path?
So I knew from a very little age that I wanted to go into the military or into law enforcement or search and rescue. And going through high school, everybody knows about the United States Naval Academy and Military Academy. But doing some research, I found out about the United States Coast Guard Academy. And to me, the Coast Guard, we do everything from environmental protection to search and rescue to law enforcement to attending buoys. We're a very diverse agency, and we can do everything. And that appealed to me, as well as our life at sea.
So once you decided you wanted to follow that path, what did you know you needed to do in high school in order to be accepted into that program?
So for me in high school, I think it started with academics, staying engaged in academics, being in the honors program, taking the AP classes, and being able to demonstrate a high caliber student to be a good applicant for the academy. But that's just a small part of it. I think the academy is looking for well-rounded individuals, and so for me that was also on the sports fields. Mine weren't necessarily fields. I was a water polo player and a swimmer and a rower, and so for me I think the athletics and then being involved in other things. I was involved in First Robotics, which is a high school robotics program. I was involved actively doing community service. I was involved in the Boy Scouts. So being well-rounded and having a lot of diverse background, I think makes a good applicant.
Well, you can expect a lot of emails from me later this year because this is my second year doing the first tech challenge with my students, and we're learning together as we go, and we have lots of questions, so you'll hear from me. I was wondering if you could kind of run through the robot for us and tell us some of the features that this has.
Of course, I'd be glad to. So this is a Seabotics LBV Little Bethic Vehicle 200. What that means is that it can dive up to 200 meters beneath the surface without being crushed under the pressure of the ocean. This particular ROV has camera and light configuration. It has a claw that can extend and deploy and grab samples off the bottom. It has a blue view sonar, which is gives us our eyes and ears when we have zero visibility. It has 4 thrusters. It can go up and down, side to side, forward and backwards, and is driven off of one small computer device with a tether. It's very portable and very easily deployed, and it's a great platform to start learning how to use ROVs and how to get down onto the bottom and do research before you jump up to the deep reef.
And I'm going to get to drive it in a little while, so stay tuned. Gabe is going to be coaching me, and I love that you have created this sort of mentor model in your program where you've put him in a position of leadership to teach other cadets, and I think that's so valuable. What has that experience meant to you as becoming an authority within this team that you're on?
So for me, becoming an authority within this team, it's given me a lot of different opportunities around the globe, as well as lets us develop cadets, and it shows that other cadets can get to that position, and so it creates more of a drive, I think, and allows more cadets at the bottom levels, whether they're freshmen or sophomores, to see that there's other opportunities instead of just the rigors of the military life at the academy, and creates an escape, if you will.
It gives you an opportunity to distinguish yourself and network. We have a question. Elise?
So the question, I think, is for you, Shannon. It's, are there programs available for high schoolers to get into robotics?
Oh, there are many programs for high schoolers to get into robotics. The one that we mentioned that Gabe experienced in high school is the First Robotics program, and there are a number of others that I can't think of off the top of my head right now. First has 4 levels of engagement. There's the junior FLL, then there's the First Lego League. That's what FLL is, First Lego League. Then the third tier is the one that my students are involved in, and that's the First Tech Challenge. And then there are the big kid robots, as I call them, the First Robotics Challenge, and these are really big and expensive. So sort of an analogy, this size ROV is more on the scale of what the First Tech Challenge might be like, but on a land-based environment rather than water. And the deep reef ROV that we will see later is more on the scale of what they might do in the First Robotics Challenge. But there's lots and lots of other opportunities out there for students to get involved in robotics. And those opportunities can take you in so many directions. Do we have another question?
We do. This one's for Rich Sanders, and it's, how can we use ROVs for research?
Well, the ROVs for research give us, as Cadet Patterson, as Gabe said, they really give us our eyes and ears for starters, so that for today and for this cruise, for example, and others, we will be looking both through camera and also using sonar to get some idea of the condition, size, shape of a wreck or other structure. Also, on this ROV, we have an additional sensor, and ROVs can be configured in many, many ways. We're carrying a dissolved oxygen sensor, and we're also collecting salinity, temperature, and depth data as we go. So the limits to the ROVs are really only by the imagination of the folks and the operating conditions and the limits of operating conditions that we have, which I'd like, if I can, to ask Gabe real quick about your experiences in that sense with currents and perhaps some of the other locations with the Seabotics real quick, what you can say about the operating conditions.
So for this size of an ROV, you're very limited by the current. We can't operate anything more than a knot to a knot and a half without losing control of the ROV and having it pulled away from us. However, I can tell you for a fact that it'll operate in water temperatures up to -5. We've operated it under the ice in the Arctic and had no effects. We've also operated down at depths of 300 feet. So there's a lot of capabilities to the ROV, and you can put sensors on it, you can look at things, you can do whatever you can imagine.
Okay, do we have another question?
We do. We have one last question for Gabe. Do you ever worry that you might crash the ROV?
So fortunately, our ROV is very durable, having crashed it many times. The biggest fear whenever we're operating off of a ship or a small boat is there is a tether that goes from this ROV back up to the control console on board. And our biggest fear is trying to keep that tether out of the prop. You don't want to foul the prop and prevent the ship from maneuvering. So never done that one while ship's underway. But yeah, there's always a little bit of a fear about breaking it, I think.
I think what she meant to ask you was a question probably from one of my students is, are you afraid that Miss Donovan is going to crash your ROV later when she gets to drive it? Hopefully not. Elise, back to you.
Okay, I said the last question was the last question, but it's not. It was the second to last question. The final question is, what materials are the ROVs made out of?
So ROVs can be made out of a wide range of materials, from metal to plastics to silicons. Ours is primarily plastic. We do use metal screws to hold it together. We also have pressurized tubing here that has all of our electronics. Honestly, ours is very easy maintenance. It's plastic. If you go out and look at the one outside, that one is also primarily plastic. But as you get up to bigger models and to your more working class ROVs, those are going to be more metal. They have the capability of cutting things and grabbing things. And it's all in the eye of the beholder. So whatever you want your ROV to do, you can build it in whatever you want.
Thank you very much. We are running out of time. We're going to head back to Elise for a wrap-up.
Well, I want to thank both our guests and our viewers for joining us today. And I also want to remind you that we're going to be continuing to broadcast live online at interspacecenter.org/RIX. We have 2 more scheduled shows today at 7 and 1. Once again, for joining us and continue to explore with us.